25. 25 minus 13, which is 12. 13 minus 4, which is 9. 4 minus negative 2, which is 6. Negative 2 minus negative 5, which is 3. Negative 5 minus negative 5, which is 0. Negative 5 minus negative 2 is negative 3. And negative 2 minus 4 is negative 6. Therefore, our second difference is a constant 3. So this is a quadratic. In fact, this second difference tells us even more. This is a quadratic where the coefficient of x squared is 3 halves. Whatever this second difference is, the coefficient of x squared, you would divide by 2. It's about 6 tables here. So 31 minus 24 is 7. 24 minus 18 is 6. 18 minus 13 is 5. 13 minus 9 is 4. 9 minus 6 is 3. 6 minus 4 is 2. 4 minus 3 is 1. Therefore, our second difference is 1. This tells us that we have some sort of 1/2 x squared equation. There's more to it, but we know the coefficient of x squared. Negative 54 minus negative 40 is a negative 14. Negative 40 minus a negative 28 is a negative 12. Negative 28 minus a negative 18 is negative 10. Negative 18 minus 10, negative 8. Negative 10 minus 4, negative 6. Negative 4 minus 0, negative 4. 0 minus 2, negative 2. Again, our second difference is constant. This time we have a negative 2. This tells us our coefficient of x squared is a negative 1x squared. In fact, this time we're looking at some sort of parabolic curve that goes like that because of the negative. All right. 7 minus 6 is 1. 6 minus 5 is 1. 5 minus 4 is 1. 4 minus 3 is 1. Looking linear, and then check this out. So this is some sort of absolute value V graph. It goes down in a linear pattern, and then it comes back up in a linear pattern. And our last one, 3.5 minus 2.5 is 1. 2.5 minus 2 is 0.5. 2 minus 2 is 0. 2 minus 2.5 is negative 0.5. 2.5 minus 3.5 is negative 1. 3.5 minus 5 is negative 1.5. 5 minus 7 is negative 2. The second difference is 1/2, 1/2, 1/2, 1/2, 1/2, 1/2. So that means that our x squared is going to be positive, and 1/2 of a half is a 1/4. So we're finding the coefficient of our x squared. So to know something's a parabola, it needs to have symmetry. That means there's a mirror image. So when you have your curve, you can draw that mirror image line. It's either a smile for a positive x squared or an arc for a negative x squared. The vertex point right here is either going to be a minimum if it looks like a smile for a positive x squared. And if you have a negative x squared, the vertex is going to be a maximum. It'll cross the y-axis one time. For the y-intercepts, it might have 1, or none, or 2. 1, none, 2. 2 at most because of the x squared. And your rate of change, basically the second difference is constant. So if we look down here, A is a parabola with a maximum vertex. This is going to be some sort of possible cubic because this is a cubic because it changes direction, increasing, then decreasing, then increasing. That's why it's an x cubed. This is an x squared. It's a positive x squared with a minimum vertex. This one would have been a negative x squared. Letter D is not an x squared. This is some sort of absolute value x. In fact, there has to be a negative out front as well. This is looking like another lovely x squared, probably a fraction out in the front because it's so wide. F is an x squared. This one's shifted up with no x-intercepts, but it still does have a minimum vertex. And letter G is linear, not an x squared. So this is again just explaining that if the x squared is positive, we have the end results both being positive. And if you have a negative coefficient of x, your end results both go down. So again, this is a max vertex, which is a negative x squared. A min vertex, which is a positive x squared. A max vertex, which is a negative x squared. And a minimum vertex, which is a positive x squared. Our second section, well, let's start with the first part. Our second section is going to be to estimate how many zeros something has. This first graph is actually shifted up 3, so it never crosses the x-axis, so this has no x-intercepts. In our second graph, this is factorable, x minus 3, x plus 1. So it intercepts at -1, and it also intercepts at 3. So this has 2 x-intercepts. This is perfect squares. In fact, you could take out a -1, which might be helpful. And this factors into x plus 4 squared. So that means both of the x-intercepts are at -4. Both of them. So since they're both the same, this only has one x-intercept because both of the factors are the same. Once you find your 2 x-intercepts, you can find your line of symmetry, which is directly in the middle. So the goal is to find 2 symmetrical points of x-intercepts, and then directly in between is your line of symmetry. So right here we have an x-intercept at 1 and 3. Therefore, our line of symmetry should be at 2. So we're going to figure out how we can find that if you don't have numbers and you just have an A, a B, and a C. We're going to solve this with letters. So this is our standard form. We want to figure out, this is our y-intercept. So we're going to name that point right here. And If we subtract the c from both sides, we get 0 equals ax squared plus bx plus 0. And if you take out your greatest common factor, we have x can either equal 0, which is this point, or we have ax plus b equals 0. So to solve that, we would subtract b, divide by a. So this point right here is negative b over a. The point directly in between 0 and negative b over a, right here, would be negative b over 2a. It would be half of that. You would add the 0 and the negative b over 2a and divide by 2. So to find the line of symmetry, we can always use this lovely new formula of negative b over 2a. Before this moment, we've always factored and solved, which we just did these first two problems somewhat doing that way. Let's think about negative b over 2a. We have ax squared plus bx plus c. A is 1, the coefficient of x squared. B is negative 2. C is negative 3. So if we plug that in, we would have x equals negative 2 all over 2 times 1. So we have 2 over 2, which is 1. This is telling us, if we look at our graph, at 1 is our line of symmetry. If you go back and remember this in factored form, it was x minus 3, x plus 1. So at 3 and at negative 1 are our intercepts. So that's our parabolic curve. Negative b over 2a with the next problem. This is our b, and our a is 1. That would be negative 8 over 2. So our line of symmetry would be x equals negative 4. This factors into x plus 4 squared. So in this case, our x-intercepts are at negative 4 as well as our line of symmetry. And we're going to factor this one the long way. So we have a negative, actually we don't need to factor. What am I doing? We're going to do our line of symmetry, negative b over 2a. That's negative 10 over 2 times negative 3. Negative 10 over negative 6. So our line of symmetry is at 5/3. You can also think of that as 1 and 2/3. So you can plug in a couple points on either side to get the graph of this. But since we're only asked for line of symmetry, we will move on to our last section, where now we need to find the actual vertex. So you find the line of symmetry, negative b over 2a. And then you plug the x value in to all of your x's. So we have negative 3 times 1 squared plus 6 times 1 minus 7. So we have negative 3 plus 6 minus 7. So y would equal 4. So our ordered pair vertex is 1, 4. And because we have a negative x squared, we know this has to be a maximum point. In our second problem, we have negative 2 over 2 times a fourth. That's negative 2 over 1/2. And to get rid of that 1/2 on the bottom, multiply by 2, so our line of symmetry is at negative 4. When you plug the negative 4 into each of the x's, okay, so then you plug the negative 4 back into every x value. So 0.25 times negative 4 squared plus 2 times negative 4 plus 3 is going to give you the y value of your vertex. So 0.25 times 16 is 4, not 8. That'd be 16 divided by 4. Plus 2 times negative 4 is negative 8 plus 3. So our answer is negative 1. Therefore, the vertex point is negative 4, negative 1, and this is the maximum because we have a positive x squared. And the grand finale, our vertex. Almost seems like it'd be easier to do if we know the two y-intercepts because the vertex is directly in between. So thinking of it this way, the vertex would be right here at 2.5. To do the negative b over 2a, we need to do the double distribution method. So x squared minus 4x minus 1x plus 4 would give us a negative 5 for b and a 1 for a. So again, our vertex is 5 halves. That's the x value of the vertex. You would need to plug that in to solve for the y value. So 5 halves minus 1 times 5 halves minus 4 will give you the y value. So this would be 3 halves times 5 halves minus 8 halves, which is negative 3 halves. So our y value is negative 9/4. So the ordered pair, 5 halves, negative 9/4. Where's my step?